Okay, now that we know our exact values between 0 and 90, sometimes you're asked for exact values that are greater than 90 degrees. In order to work these out, we have to find the related acute angle, and you can do this from the symmetry of the graph. For example, in the sine wave here, we can see that this value here will appear again over here, and again over here. And if we went back far enough, it would appear again back here somewhere. Same with the cosine wave. There are values that appear here that are the same over here, and if we kept going or backwards and forwards, you'd find similar values from the symmetry of the graphs. So what we have to do, we have to find the related acute angle and then apply that to our exact value table or our triangles and squares. I'll show you how this is done. Again, instead of drawing out the graphs every time, we use our aid of all sine, tan, cos to find out where the graphs are positive and negative, and what angle you're looking for to get into the certain quadrants. So to find the exact value of sine 330, we have to find the related acute angle for this. So draw out your all sine, tan, cos and find out where 330 is. Now, thinking it going round like this, 180 to 270, we go round to about 330 there. Now we should know that the related acute angle is found by subtracting from 360 to get to here. So that would be 30 degrees. We would subtract 30 degrees to get to this value here. The next thing we have to consider is the sine positive in this quadrant or is it negative? And because we're in the cosine quadrant, we have gone back 30 degrees, but the sine is negative. The graph is negative in this quadrant. So the answer to sine 330 is negative the sine of 30 degrees. So two things there, find the related acute angle and then see if the value is negative or positive by understanding your all sine, tan, cos. Once we've done that, we can think what is the exact value for sine 30 is, and that would be a half. So this will come to negative a half. Okay, let's look at cos of negative 45. So if we think of 0 being here and 45 being here, then negative 45 would actually go backwards. So the related acute angle here would be a subtraction from 360 to get to here, which would be 45 degrees. We then look at what quadrant we're in. We're in the cosine quadrant, so cos is positive here. So it's going to be positive 45. Again, thinking of exact values for cos of 45, it's 1 over root 2. Okay, and the final example here, we've got tan of 7 pi over 6. So we should notice this is in radians. The easiest way to do this calculation is change the radians into degrees first and then do what we did in the first two examples. So to change radians into degrees, you multiply by 180 and divide by pi. So we'll do that here. So the pi's will cancel out. I would divide the 180 by 6 first, and that's 30, and you times it by 7, you get 210 degrees. So what we're really finding here is the tan of 210 degrees. So we'll go back to my diagram. There's 0, 90, 180, we're at 210. Again, to find the related acute angle, we think we'll need to add on to 180 to get to 210, and that would be 30. We then consider if this is positive or negative. We're in the tan quadrant, and it's tan we're looking for, so it's a positive value. So tan of 210 is equal to positive tan of 30, and positive tan of 30 is 1 over root 3.